Welcome to the General Chemistry 2 class. This section is on acid-base equilibria and salt equilibria. This lesson is about acid-base properties of water. Let's begin. In this lesson, we will discuss the acid-base property of water. From the previous lesson, we learned that water could act as a Bronsted-Lowry base in the presence of an acid like acetic acid, and a Bronsted-Lowry acid in the presence of a base like ammonia. Thus, water exhibits properties of both acids and bases. It is capable of accepting and donating a proton. Water can undergo an acid-base reaction with itself to produce hydronium or hydrogen and hydroxide ions. This process is called autoionization. For simplicity, we will use the following reaction for autoionization. Water produces hydrogen ion plus hydroxide ion. The autoionization of water has a corresponding equilibrium constant. This constant is called the ion product constant, denoted by the letter Kw. Like any equilibrium constant, this value changes with temperature at 25 degrees Celsius. This value is equals to 1.0 times 10 raised to negative 14. Pure water consists of equal concentrations of hydronium or hydrogen and hydroxide ions. Thus, at 25 degrees Celsius, the concentration of these ions is equal to 1.0 times 10 raised to negative 7 molar. For any aqueous solution, the same value of Kw applies at 25 degrees Celsius. The acidity or basicity of an aqueous solution depends on the concentrations of hydrogen and hydroxide ions. A neutral solution consists of equal concentrations of hydrogen and hydroxide ions. A solution is acidic when hydrogen ion concentration is greater than hydroxide ion concentration. When the solution contains more hydroxide ions than hydrogen ions, then the solution is basic. Example number 1. An aqueous solution contains 8.74 times 10 raised to negative 4 molar hydrogen ion. So A. Calculate the molar concentration of hydroxide ion, and B. Determine if the solution is acidic, neutral, or basic. So, solution. For A, the ion product constant equals the molar concentration of hydrogen ion times that of hydroxide ion. Rearranging this equation gives us the equation for calculating the molar concentration of hydroxide ion. Unless otherwise stated, let us assume that the temperature is 25 degrees Celsius. Thus, K is 1.0 times 10 raised to negative 14. Substituting K and the molar concentration of hydrogen ion, we obtain hydroxide ion concentration 1.14 times 10 raised to negative 11 molar. And for B, since the calculated hydrogen ion concentration is greater than hydroxide ion concentration, then we can conclude that the solution is acidic. Example number 2. Given that a solution contains 0.47 molar of hydroxide ion, let us A. Calculate the molar concentration of hydrogen ion, and B. Determine if the solution is acidic, neutral, or basic. So, solution. For A, the ion product constant equals the molar concentration of hydrogen ion times that of hydroxide ion. Rearranging this equation gives us the equation for calculating the molar concentration of hydrogen ion. Unless otherwise stated, let us assume that the temperature is at 25 degrees Celsius. Thus, K is 1.0 times 10 raised to negative 14. Substituting the molar concentration of hydroxide ion, we obtain hydrogen ion concentration, which is 2.1 times 10 raised to negative 14 molar. And for B, since the hydrogen ion concentration is less than of hydroxide ion concentration, then the solution therefore is basic. To summarize, water can act both as a Bronsted-Lowry acid and a Bronsted-Lowry base. The autoionization of water produces hydrogen and hydroxide ions. And lastly, the ion product constant is the equilibrium constant for the autoionization of water. And that would be all for the part 2 for the acids and base, the acid and salt equilibria. So now, since we all know about the acid-base properties of water, let us proceed to a quiz. So, number 1, select the correct answer. This is the process in which water reacts with itself to produce hydrogen and hydroxide ions. Is it A, autocatalysis, B, hydration, C, autoionization, or D, solvation? Next, number 2. This refers to the equilibrium constant for the production of hydrogen ion and hydroxide ion from water. Is it A, ion product constant, B, water concentration constant, C, water hydration constant, or D, vapor pressure? Let us proceed. Number 3. Which of the following is the correct expression for the ionization of water? So, is it A, B, C, or letter D? Next, we have number 4. Which of the following is true about a neutral solution? Is it A, where hydrogen ion is equals to hydroxide ion, or B, C, or letter D? Select the best answer. We have now number 5. Which of the following is true about a basic solution? Is it A, where hydrogen ion is less than of hydroxide ion, or B, where hydrogen ion is equal to the hydroxide ion, or C, where hydrogen ion is greater than hydroxide ion, or letter D, where hydroxide ion is equals to 1.0 times 10 raised to negative 7 molar at 25 degrees Celsius. Select the best answer. Number 6. Which of the following is true about an acidic solution? Is it A, B, C, or is it letter D? Next, consider an aqueous solution consisting of 0.0459 molar hydrogen ion at 25 degrees Celsius. So the question is, what is hydroxide ion? Is it A, B, C, or letter D? Number 8. So, consider an aqueous solution consisting of 0.0459 molar hydrogen ion at 25 degrees Celsius. The question is, determine if the solution is acidic, basic, or neutral. Is it A, acidic, B, basic, C, neutral, or D, cannot be determined? Number 9. Consider an aqueous solution consisting of 8.34 times 10 raised to negative 9 molar hydroxide ion at 25 degrees Celsius. So, what is hydrogen ion? Is it A, B, C, or letter D? Lastly, we have number 10. Consider an aqueous solution consisting of 8.34 times 10 raised to negative 9 molar hydroxide ion at 25 degrees Celsius. So, we have the question, determine if the solution is acidic, basic, or neutral. Is it A, B, C, or letter D? And this is the end of our discussion for today. So, I hope that you learned something. I hope you will apply it. And always remember to be like Proton, stay positive. Thank you, and that would be all.